Hey everybody, Patrick McFadin, live at the Strata booth in New York, the Javits Center. I'm here today with Karthik Ramasamy from Streamlio, but probably more famous about something else. Tell us a little bit about yourself. This is the key part. You need to say this.
Awesome. So I used to work before that, before starting Streamlio, I used to work at Twitter. And
I've heard of that company. I've used it twice.
Oh.
Yeah.
It's a rock solid company. So, it is. I was managing the real-time compute team at Twitter.
So I think a lot of people know about your favorite project in the Apache ecosystem, Heron. So Apache Heron, I know a little bit about it. I probably know more about Storm. So you tell me, what's the difference between Storm and Heron? Like, that was the project you worked on at Twitter, right? Yeah. So tell me more about that.
Heron is probably rewritten from the ground up compared to what Storm was, because Storm had a bunch of issues in production, ranging from GC issues, operationally not stable, and not highly scalable, and not high throughput and low latency. So what we did is we have to rethink how the streaming framework should work. So one of the fundamental design changes that we made is we moved from a threaded architecture to more of a, what you call a process architecture, which allows you to have isolation at all levels, at the individual stream operator level, and individual container level, and the individual topology level, so they don't intermix each other. And then
so that's instead of having multiple threads running on a single machine.
Yes,
each one is a
process
isolation from every single process.
Yes. So that way what happens is it's productionally gotten much stabler, and people have the ability to restart certain amount of machine, and it's predictable resource allocations and all the various stuff like that. And
well, the process, so that's actually an interesting thing for resilience.
Yes.
Idempotent data, being able to restart your data. I think this is a part of distributed system that's interesting, is there is no magic, because you have mutable data can be restarted, but you have to be ready to do that.
Yes, you should restart the process, and you should replay whatever it has been doing so far, so that it's very resilient. And it's very important in things like Twitter, because of the fact that it runs like big jobs, like 700, 800 containers per job. So how do you even spot the problem? Even if you spot the problem, how do you go and troubleshoot it, right? First of all, spotting the problem on an 800 machine containers, how are you going to do that? So it's, first of all, like the fundamental change in architecture, and how to use this architecture to automatically figure out where the problems are, so that when you are in the middle of a Super Bowl ad campaign that's going on, you don't want the system to go down. Even if it goes down, you should be spotting it within a few seconds and restart it wherever it has to. So ultimately, the end game, once it got deployed, we got like 10x reduction in incidents. That's huge. We had a good night's sleep, by the way.
I think that's probably the best part of any good distributed system, is when you can sleep at night.
Yes, exactly.
I used to work in ops, and I used to get woke up at 2 or 3 in the morning because some relational database wasn't working at 2 in the morning.
Yes.
I don't want that anymore. I want to sleep at night and wake up and say, oh, there's some infrastructure that failed, but it's okay.
That also means programmers do not like doing ops jobs all the time.
No.
Right? So they can write more features and add it to the software, and they'll be happy. So overall it's a good package, right? And the reduction in number of incidents. So that's what we achieved, and we also achieved like 3x to 5x reduction in cost also.
All right, so I want to try a Heron. I want to try out what you guys are Streamlio. What can I do? Where can I go?
Just go to the Streamlio website. You have a sandbox already available at www.streamlio.io. You download it, and you can start the Docker container and ingest data. It will automatically compute some simple data transformations, and you can produce output. Right away, you can try it out. That's a glimpse of what you can expect.
Try it today. Yeah.
Yes, you can try it today.
You could be a stream processing genius, just like Karthik, with a Docker image. You've Dockerized yourself. Well done.
We Dockerized. Everything is containers for us.
All right, thanks, Karthik. I appreciate it.
Thank you. Nice meeting you. Nice pleasure talking to you.